Hello everyone, welcome to this video. My name is Emerson Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm gonna show you how we can use Landsat images to monitor NDVI values over the last 40 years. It's a very applicable tutorial. When you want to use all Landsat missions together, you need to do some sort of programming or scripting in the Earth Engine platform, enabling you to bring all of them in a single image collection for the further processing. So stay with us in this tutorial because it's very helpful and applicable in the projects you are dealing with the Landsat images, specifically for the long-term monitoring. So as usual, for the first step, identify your region of the interest or draw your region of interest by drawing tools available here. For example, I want to work on an agricultural area in the northwest of Iran, my own country. Through the satellite imagery, through the satellite view, you can see agricultural fields in the southwest of Iran. You can see them, and also they are really dense and big areas. For example, I select a region here through the rectangle tools available in the drawing, and then I select a part of this region by rectangle. So for the next step, to have a focus on your study area, use map.center-object for the geometry to have focus on your study area when the code is running, just like that. So in the next step, we need to call all Landsat images available since, for example, 1984 to 2024. So I'm gonna start with a Landsat 4 that is available for 1980s, and here make a new variable. We have a Landsat 4 equals to. Through their search places and dataset, you can call Landsat images for all missions. Collection 2 level 2 is available. Why collection 2 level 2? Because collection 2 level 2 is a kind of product that is corrected atmospherically and radiometrically and also geometrically. So, and you don't need to do any further pre-processing step, just you need to call satellite data and use or apply some scale and factor that is really easy to do a conversion to a surface reflectance values, and then use it for the further processing, and no need to deal with any kind of atmospheric correction like we have already done, such as we did in previous, for example, 5 years ago or 10 years ago in some desktop software such as NV or ArcGIS, and through different algorithms such as quick atmospheric correction or I don't know, the different functions that were available in that time. But now everything is ready to use, and you just download satellite data and pick it and use it for the further processing. The main reason that data are released correctly is that NASA and ESA, or the data providers, want you to have focus on the information extraction and data processing rather than dealing or struggling with the pre-processing step or something like that. The main goal is that the users have focus how to extract valuable information from the existing data. So let's go. Through the search places and data set, type Landsat 4 collection 2. Collection 2 level 2 is available. So, and here you can see that Landsat 4 level 2 collection 2 is available. Import it as an image collection into a code, and then I want to select all the surface reflectance bands because I want to do NDVI time series analysis by the bunch of Landsat collections collected from the images collected from the different Landsat missions actually. If you go to the data descriptions, specifically in the bands, you can see that all the surface reflectance bands starting with SR, meaning surface reflectance, with the same scale and offset that should be applied on each data or each band separately. So now I want to select surface reflectance bands, and here type SR, but the rest of thing and the rest of the letters is not important here, and so I use this sign here to show that only I want to select those of bands starting with SR for this region for the specific period of time through the filter date. To know Landsat 4 is available for which time spans, you can see in the data set availability, it's available since 1982 to 1993. So I'm using, for example, filter date here, and filter date is vary for the Landsat 4 and also will be vary in the Landsat 4, 5, 7 and also Landsat 8, because each Landsat mission's data are available for a specific period of time. So filter date is 1983, for example, to from 1982 to 1994. I run the dates, and then I want to call those of Landsats that are bounding to this region. And the region is the geometry and already defined here. So you can see here that now I printed to see that how many Landsat 4 images available for this period and this location. Image collection is computing, 54 elements is available, and most of them available for the 1980s and also 1980, 1981, 1988 and 1990. You can see that the data are available here, and unfortunately there is a huge gap in the Landsat images before 1980s, and in the best situation, in the best condition, you will have access to the regular Landsat data since the second mid of 1980s. And so and for the next step, you can use cloud filter to filter those of images that highly covered by the cloud. For example, here make a new filter, Earth engine.filter, less than filter, helping us to call only those of Landsat images which cloud cover less than, for example, 45. We prefer to use a mid-range to select and filter Landsat bands here. You can see that all the surface reflectance bands are available, but in order to remove the Atmos opacity or cloud QA, you can add the B here to only have access to the multispectral bands or surface reflectance bands here. And then I'm applying a cloud filter with 45% here, and then I'm running the code, and you can see that 49 elements are available. And as you can see, the pass and row for this region is 165 and 38, and all the images for this region have the same pass and rows. So, and for the next step, I want to use a Landsat 5 images to call all of the bands simultaneously, all of its bands simultaneously. But before then, I need to make a function to apply a scale and factor on each bands for Landsat 4, 5, and 7, and also calculate the normalized difference vegetation index. So here, the function name is, for example, I want to make a function. The function name is NDVI TM, ETM, and yes, that's the NDVI, or it's a kind of function that we can use for the thematic mapper sensors in Landsat 4 and 5, and also can be used for Landsat 7 images that carry enhanced thematic mapper sensor. So each input image in this function considered as an IMG here. First, make a variable as bands in order to apply through the multiply and add the scale and factor that we discussed earlier. So go to the data description and copy the scale and factors available. The factor or offset is minus 0.2. Just copy a scale value and paste it into code, and then add minus 0.2. The coefficients are same for all Landsat images. And then for the next, we need to calculate the NDVI equals to, so instead of the now we want to get all the bands that is corrected in the previous step, and now through the normalized difference we want to calculate the NDVI, normalized difference vegetation index, can be calculated through the normalized relationship between near infrared band number 4 and the red region of electromagnetic spectrum or band number 3. So, and the output will be renamed as NDVI, and the function should return a result that is NDVI. NDVI with all the property of input images, img dot property names, just like that. It's very simple and useful method to combine all Landsat images together into a single collection. First, we need to call each Landsat images with own filter date and bound and cloud cover, and then convert their values from the digital number to the surface reflectance by the constants available in the data description, and calculate the NDVI, and finally apply the function on each collection separately, and then merge the results together. I will show you in the next step. So through that map you can apply the function. The function name is NDVI, TM and ETM plus. This is a function that can be used for all the satellites carrying a thematic mapper and enhanced thematic mapper, as we already mentioned. So here I want to print Landsat 4 images. Now the Landsat is not defined, Landsat 4. Number 4 was missed here. And now you can see that 49 NDVI values available, each element including one NDVI band. So do the same process for the Landsat 5 and Landsat 7. It's very simple. Just copy this part of code, and also in order to have in order to see the better code and also have enough space for programming, I make their main panel a little bigger, and then paste the Landsat 4 variable with a little change. As you can see, the only thing changed for the Landsat 5, because Landsat 4 and 5 both have same both of them carrying same sensor, both of them carrying thematic mapper sensor with the same bands, spatial resolution and also temporal resolution, and radiometric resolution, and also the spectral bands. So just we need to change the start date and end date. To do this, first call Landsat 5 collection to level 2 here. Through the search places and dataset, you can find Landsat 5 collection to level 2 in the code as an image collection 2, and then go to the data description. You can see that the same scale and factors and the same band numbers, and the only thing is changing a collection snippet and start and end date. These data available since 1984 to 2013. So 1984 to 2013. And also surface reflectance bands, image collection should be changed to collection number 2, and then the function for NDVI applied on each images under Landsat 5 name, and then we can print the result to see if it's working well or not. So Landsat 5 images, image collection is under computing. More than 500 images are available. As you saw that a large number of images available after Landsat 4 because the availability or accessibility of data increased after Landsat 4 and low number of gaps in the satellite imageries caused higher number of images are available. And one important thing is that the period of imagery for the Landsat 5 is much bigger or longer than a Landsat what we have in Landsat 4. And now you can see that 500 images with the mid-range cloud cover is available for the for the region of the interest, and you can see that the pass and row for this region in all images is same, 165 and 38. And also we have some frames that are different than each other. For example, some of the frame code is 165.38, and some of them has a different code such as 166.38. In order to see that, in order to check that our study area in which frame covered better without any gaps, we need to go to the Earth Explorer website and check our study area to see that it is covered by which regions actually. So here just type Earth Explorer, and here you can see that through the search criteria, I remove a space here first. Here through the search criteria you can find your location. My location is southwest of Iran, and as you can see we have selected this region as a study area, and then go to the data set and through the Landsat option go to Landsat collection 2, Landsat 8. It doesn't matter Landsat 8, 7 or 4, just you need to select one of the Landsat images to see that which pass and row covering completely your region of interest. So go to the results now, and here for example we have a frame with pass and row 165 and 38 that is covering whole of a study area very well. And also there is another this covering very well, and also no other pass and row detected here. Maybe if a little browsing here you will find some new frames here, but no, just this covering well our study area. The only things you need to do is to select the pass and row that you sure about it, and also this is 165 and 38. Back to the code and use a filter for the pass and row to keep all the images that's covering your entire study area. So here I make a new filter for pass and row. That filter Earth Engine dot filter dot equal. By the dot equal we can set as filter all the existing images through a single pass and row values. If you go to the data descriptions into the properties, here you can see that there are some properties that showing pass and row, that is 166 and 38, but we want to call those of properties. We want to have those of properties with pass number 165 that is covered completely our study area as I showed you here, and 38. Again, dot filter, another equal filter dot equal, and this time instead of pass WRS row, and it is a 38, just like that. So we can use this filter for all existing images in Landsat missions to have an integrated or to make integrated data collection over the 40 years. When you want to do long-term time series analysis, it's very important to set a same cloud cover, to use same spatial resolution, and also use same spectral indices and the same bands here. It's very important, and also it is also including pass and row to have access to a single frame in each date and cover and monitor the NDVI changes. So run your code again, and this time you will see that, for example, from 500 images only 251 elements are available. So in the next step we can try this code for Landsat 7 with a little change. For example, just I'm copy Landsat 5 for Landsat 7. Why we don't use Landsat 6? Because as you know, Landsat 6 exploded and never its mission started, and no, we don't have access to any Landsat 6 images. Only Landsat 7 after 5 is available, and then through the through the search places and dataset, type Landsat 7 collection to level 2 images. Landsat 7 collection to level 2 images are available. So import it into the code, and here you can see that the Landsat 7 as an image collection number 3 is available. So here it is. And now for the next step, we need to change start date and end date. The start date is 1999 and the end date is present, for example. So here I want to change the start date from 1999 to 2024 to call all the Landsat 7 images into our programming step. And because when we have access to the several satellite data or extra satellite data, we can have a higher temporal frequency when we are using Landsat 7, 8 and 9 together, and also strictly increase the temporal resolution and provided higher temporal frequency in our estimations. But you should consider or you should you should pay attention to the SLC-off problem in the Landsat 7 images that happened after 2002. For example, if you go to the net and search about Landsat 7 SLC-off problem, you will find a lot of information in this regard. For example, as you can see in the USGS, there is a link that explaining very well about the Landsat SLC-off or dropped line problem in the Landsat 7 data after 2003. So I'm trying to reload this. Yes, as you can see, after 2003, because of SLC problem in the Landsat 7 images, we faced with a dropped line, a dropped scan line in the Landsat 7 images, and caused many information dropped or failed in each frame. And now we can solve this problem by some further processing technique that helping us to make a better visualization for our estimations. So if you go back, you can see that from the 2003 this problem occurred from the May 2003. So now we can make two Landsat 7. Landsat 7 before Landsat 7 SLC on first, SLC on from 1999 to 2003 month May. As you can see, the date, the exact date is, yes, since the last day of May 2003 this problem occurred. So here, for example, I want to use those of Landsats available since 1999 to 2003, and for example the 1 day earlier that this problem occurred. And also we can use this code to print it, Landsat 7 SLC on, and you will see that for this period only 34 elements are available with cloud cover less than 45%, and in this pass and row that is selected. And now for the next step, we need to make a function for SLC-off data. Here I'm making a function. For example, this function is SLC-off, and each input image is considered as an IMG, and also in the body we can write a code to do the pre-processing and to calculate the NDVI and also to fill the gaps. First, I can copy NDVI process and also scale and factor, applying scale and factor from the previous function, and copy and paste it into the existing function here. And for the next step, we need to set a filter to filter and blend it with the original image to solve the problem. So I want to make a filter here, for example, Earth Engine so here, for example, get the NDVI images and through the focal median or focal mean, we can solve this problem. So focal median and focal mean, both of them is helpful, and you can use it to define an average filter to solve the problem. So for example, I want to make if you want to have to the age information, would be better to focal median. So, and there are some arguments that should be filled in this function. For example, the radius is 30, and also there are different criteria that you can consider for your calculations. As my target resolution is 30 meter, now I set, for example, 30 as a radius in this calculation, and the kernel type as in satellite image, including pixels with the rectangle structure. I use a square as a window shape actually, and the units as the satellite data is its spatial resolution is based on meter. Now I turn it to the meters or meters, and then leave the kernel and iteration as it is without any change, and also keep the default value. And then we need to combine or blend this filter with the original images. So now the filled image equals to combine the NDVI fillet dot blend. Sorry, it is my mistake. Yes, that blend with the filter. I think the filter should be blended. Yes, filter that blend with NDVI. Yes, and then the name of output will be NDVI again, and finally code returning the fillet NDVI without any gap anymore. And then we need to have img all the properties from inputs to the outputs, img.property names. So in the next step, we need to apply SLC-off function on the Landsat 7 images that's suffering from SLC-off problem. So make a new function, Landsat 7 images with SLC-off problem equals to is again image collection number 3. Just copy and paste the previous codes is enough here, and also no need to do further processing. With do just a little change, SLC-off is the name, image collection is collection number 3, and filter date is from, for example, 2003, the 1st June of 2003 to 2024. So, and with the same cloud cover, WRS pass and row is same, and also SLC-off is the function we use to calculate the NDVI. And if I print Landsat 7 SLC-off data, you can see that NDVI values in the corrected version is available. Oh, square is wrong, its name or its spell is wrong, so I can turn it square. Sorry for the problem. And now a new image collection is under computing, and you can see that more than 300 elements are available for each date. You can see that the NDVI calculated with all the properties. And also, if you want to check it out, that if any problem still existed in the image or not, you can use map.addLayer here. For example, using map.addLayer, I want to call part of a Landsat 7 SLC-off images. For example, based on the filter date, I want to call all the images for 2005 to sure that if any to see that if any problem still is in the satellite data or not. And then through the .2 bands, I make a stack and then clip it based on the border of region .geometry. And in the next step, I leave the visualization process empty, and here that is SLC-off fillet, it's the name. And finally, in order to avoid automatic visualization, I write false at the end. Save your code and run it again. So back to the code, and here we have a layer for SLC-off images that is already filled. So now I will have focused on the data, but still you can see that stripping problem still is in the image. I think something wrong in my programming and need to reconsider it to see that why still we have this problem in the Landsat 7 images. Maybe something wrong in our code, and also maybe I should use pixel instead of the square, instead of the meters. Let me try to see. So seems the gaps fill it. This is a kind of interpolation technique actually we are using to fill the gaps for the Landsat data. I think one of the important things that causing this problem for the interpolation technique is that we are using 30 pixels around for the median filter here. If we are doing based on nearest neighborhood logic here, for example, we consider the nearest pixel or the first pixel close to the targets, and also with the iteration around 5 or 10, for example, we can get a better result here, because we want to consider the closest pixel or the one pixel nearby the missed pixel, and also with 10 times iteration to find the most optimum pixel in this regard. I think the next result, in the next run, the problem will be solved based on the new criteria we defined in the focal median. The number of pixels and the number of iteration corrected to get a better results. Now you can see that we have a better or smooth image after changing some criteria. So for example, if I select one image here and then click on apply, you will see that now it's really better, because we take the closest pixel to interpolate the missed value, although still some distortions can be detectable in the satellite image, but now it is much better than before, and now it is comparable with the other available images. So back to the programming technique. After solving SLC-off problem in Landsat 7, we need to call Landsat 8 images and Landsat 9 and then merge all the Landsats into a single collection. So let me make a bigger space here for programming. So copy Landsat 7 SLC-off here, but instead of Landsat 7, we will have Landsat 8, and we need to call Landsat 8 collection to level 2 based on Landsat 8 collection 2 level 2. You can see that with Landsat 9 both are available. Here we have image collection number 4. Image collection number 4, we want to call all surface reflectance bands since 2013. Landsat 8 available since 2013, and we want to call all the data available until 2024 with the same cloud cover percentage and also the same pass and roll, but the function should be changed. The previous function, including the filtering techniques to solve the dropped scan lines in the Landsat 7 images, and the primary function, preliminary functions we created only calculate the NDVI based on the near infrared and red region in the TM and ETM plus. However, the band numbers for near infrared and red changed in the actually Landsat 8. Now we want to get NDVI for OLI images, and as you can see, OLI same scale and factor. Near infrared here is band number 4, and the red is the near infrared is band number 5, and the red is band number 4. So NDVI OLI is a function that should be applied on each available Landsat 8 images. Now I want to print Landsat 8 data to see that how many Landsat 8s are available. 200 elements available since 2013 to 2024 for a specific region with cloud cover less than 45%. So in the next step, we want to call Landsat 9 images. And also, as Landsat 8 and 9 have same spectral characteristic, we can use OLI function for the Landsat 9 too. So for example, just copy Landsat 8 variable, but this time instead of Landsat 8 we have Landsat 9 surface reflectance bands. Landsat 9 I think is available since 2022, and here you can see that it's available since the late of 2021. Import it into the code as an image collection number 5. Image collection number 5, surface reflectance since 2021 to 2024 with NDVI OLI. We can print Landsat 9 to see that how many Landsat 9 images are available. Only 39 elements for this region is available. So now all the Landsat images called in the code, and we did pre-processing steps, and we converted all the bands from the DN to the surface reflectance values, and also we solved the SLC-off problem in the Landsat 7 products. And now we need to merge all Landsat missions into a single collections, because now we have all Landsats in a separate collection, but we need to merge them all into a single collection. So make a new variable, Landsat collections equals to, so from Landsat 4 here we have Landsat 4.merge Landsat 5 merge Landsat 5 merge Landsat 7 merge Landsat 8 and then merge Landsat 9. So Now we have all Landsat images into a single collection. In order to sort all the elements under Landsat collection based on the system time start or the date acquisition, since the oldest image to the newest image, we need to sort them based on the system time start property to have all the images based on the date acquisition from the oldest to the newest. So print Landsat collections. Landsat 7, oh yes, we have Landsat 7 SLC on, and let's merge Landsat 7 SLC off. Yes, now it is running. Code is running and the new image collection is under computing. After computation is done, you can see that more than 800 elements available since 1985 so far, and you can see that they are sorted out based on the system time starts, and the dates formats are right, and also for all of them NDVI calculated with the properties. Now we can do the NDVI time series or NDVI monitoring by different functions. For example, for this single collection, you can do further analysis if you want. For example, if you want to calculate, for example, VCI, vegetation condition index, or some moisture index, now you can use it very well. For example, imagine that I want to monitor NDVI changes in this region over the last 40 years. I'm using, for example, print user interface .chart .image .series. Instead of image collection, we have Landsat collections. Instead of the region, we have geometry. Replace the reducer by Earth Engine reducer .average. I want to get average of NDVI for this region, and the scale is 30 meter based on the spatial resolution, and instead of X property, we will have system time start. So now save your code and run it. After a few moments, you can see that chart is under generating process, and we are expecting to see NDVI changes over the last 40 years in this region. Also, it's very useful programming techniques enabling you to combine or merge all the Landsat collections while they are separated into a single collection for the further processing. It's very important things that you should consider when you are working with the diverse Landsat missions to each other, to consider band differences, to consider problems that they have. For example, specifically when you are working with the Landsat 7, it should be considered very well. Chart is generating because all the bands for all the images, we have more than 800 elements with 30 meter spatial resolution. The programming or the program is a little heavy and also maybe a little time consuming to get an appropriate result, and maybe you have to run again and again to get the final result through the generating chart, because you may encounter with for example some sort of errors regarding to the programming techniques because of for example user memory limit exceeded or something like that may occur because of the too much satellite images with 30 meter spatial resolution called here, and sometimes you face with memory limit exceeded or some sort of program some sort of errors like this. But you must be patient and just try for run one after another to get the final results. For example, here you can see after a few seconds I faced with this problem, computation timeout or user memory limit exceeded or something like that. One solution is run your code again and again to get the final result, and also finally we faced with the error. And another way is, and another solution or another method can help you to solve this problem is reduce the pixel size, for example, from 30 meter to 100, and also or select a small part of agricultural region to get the average value. Then I reduce the spatial resolution from 30 meter to 100 meter to see if it works here or not. And also I use this opportunity until the result is ready to show you how we can save a part of images that we calculated for the further processing into the ArcGIS or any other kind of desktop. I want to show you how we can get export from the image collections that we created here. If you don't know about that, through the export.image.toDrive, here as you can see, if the image collection or considered data is too heavy for the further processing in Earth Engine, you can also download it from the Earth Engine by the export.image.toDrive and use it in the another program, in the another platforms such as desktop softwares for the further analysis. So now if you see the final result, you can see that the NDVI value calculated over the last years since 1986 so far, and also you can see the NDVI variations over this region and with increasing trend that it has, and also it's showing very well, and the frequency of data clearly increased after 2013 because most of the gaps resolved after 2013, and also the satellite images regularly uploaded in the servers every 16 days, and also but before that we had a lot of gaps for many months or many dates, and that's why the frequency is a little better after 2013 in Landsat 8 and Landsat 9. So, and also you can have access to the CSV format by the code CSV, and just by changing the pixel size here from 30 meter to 100 meter, we solved the problem. And also to get export from the results in image format, you can use export.image.toDrive. As I mentioned, the image argument should be equal to Landsat collection, but Landsat collection for a specific period that you want to extract. For example, that filter date, I want to get all the satellite images of Landsat for 2010, and then I want to get all the NDVIs together, and then clip it based on the region of the interest or the geometry, and the description showing the description also here showing the name of the output. Here is, for example, Landsat 2010 is the name, and scale could be 30 meter spatial resolution, and CRS or spatial resolution if you want to work with, if you want to have WGS 84, you need to use this code EPSG 4326. And also the max pixels, the max pixel for each frame that you want to download should be max pixels equals to 1E13, and the region should be geometry. And also, yes, these are arguments that we need to use them. And also, if you want to save the result into a specific folder, just set a folder name, for example test or whatever you want. When you set a name for the folder, simultaneously in the Google Drive, a new folder with this title or with this name created, and your output will be saved there. And also, to avoid from some possible errors, would be better to use .float at the end of the layer stack that you want to get export, because it's very important to consider float values, to consider the format of values as float to avoid from some possible errors that may occur during the processing steps. So, and then save your code and run it. In the right panel in the task, after a few moments you will have Landsat for 2010. Click on run and again run, and wait until saving process is done, and whenever this tab turn to the blue color like this, you can open it and also download it from the Google Drive. And also, if you faced with any problems or any issues regarding to this tutorial, feel free to reach me out and put your comments in my YouTube page. And also I will put the code link in the description part of this video in my YouTube page, and you will have access to the code. And also, if you faced with any problems in the first step, you can compare your code with mine, and if still a problem remains, you can reach me out in my YouTube page and put your comment. I will check it out. Thank you for watching us.